Hi students. So today we'll discuss electric field and electric field lines, right? So this is a part 3 in electrostatics. I already discussed Coulomb's force and its applications, and also the problems based on the Coulomb's force. No, so I already discussed. Therefore, if you did not watch, please watch it so that therefore you can understand very clearly about the electric field, right? So so welcome to my channel, that is SADHIK Physics. So physics made is very easy. Please subscribe to my channel now. So now we'll go for what is this electric field, right? So therefore electric field, right? What is mean by this electric field? So suppose there is a one charge is there now. Therefore this charge, therefore it is going to influence this charge for the certain region now. So some region is there now. Therefore within this region, this charge will show the influence. That means if any charge which is coming from outside, so which is coming from outside, then when this is outside this field, no, outside this region, this charge will not do anything to this. Therefore the force on this charge, no, it will be equal to 0. But once this charge is entered into this one now, then this will show some effect onto this one now. Then what it will do now, if there is a positive charge is there now, this also positive charge. So here this charge will be experiencing a force, outward force now. Clear? So therefore this region we will call it as like a electric field. How this region is there? This region is nothing but a sphere of influence. This charge is there. So what will be the, therefore the region is there, it will be in the form of like a sphere, therefore spherically. If the charge is here, it will show the distance here. So it will show entire the spherical region onto this one. No? This region we will call it as like a electric field. Now you try to see that if the charge is at this distance, therefore suppose R1 distance, and another charge which is at this distance, no, so which is very near to this R2. So tell me therefore force F2 and F1, which is greater now, right? So which force it will be the greater now? So this charge is very near to this one now, therefore F2 is greater than F1. Therefore the charge when it is here, so it is experiencing a greater force. When the charge is here, it will be experiencing a less force. That means what? Here you can understand this one now by this point. At this point, therefore which is very near to this one now, the field is very stronger. That means intensity of the field is very high. So when the charge is at this point now, therefore the field is slightly lesser, right? So if the charge is here, so the field intensity it will be slightly lesser. But if it is very near to this one now, the field it will be very stronger. That means at different points, no, the intensity is different. Clear? So therefore we can calculate the electric field intensity, right? So how to calculate electric field intensity? No, electric field, so intensity, how to calculate it now? Intensity, so it is denoted as like a E. So it is nothing but a force experienced by unit test charge. Force experienced, therefore how much amount of force is experienced by the unit test charge. So in this way we can calculate the electric field intensity. Therefore here we can slightly detailedly we can go through this one. No? Electric field intensity is defined as force experienced by unit test charge. So it is a vector quantity or scalar quantity? Is a vector. Why? Because force is a vector quantity, electric field is also a vector quantity. Isn't? So therefore here what is the unit for this one now? Newton per Coulomb, or sometimes no, so this also can be written as volt per, therefore meter. Clear? So therefore here is a vector quantity. What is the direction here now? What is the direction? In this direction is very important. So at anywhere if you want to calculate the electric field direction, no, there you have to keep the positive plus positive charge, that is one positive unit charge you have to keep it at that point. Therefore in which direction the force experienced by the unit positive charge, no, that it will be the direction of your electric field at that point. That means here, so wherever you want to calculate the direction of electric field, there you consider plus 1 coulomb charge, no, in which direction the force is experienced, no, that force, that direction is nothing but a direction of your electric field, or in which direction the force experienced by the positive charge, that will be the direction of your electric field, right. So, what will be the dimensional formula here now? Dimensional formula is nothing but a force per unit charge, no, force is nothing but m1 L1 T minus 2, charge is nothing but AT, clear. So, therefore, m1 L1 T minus 3 A minus 1, so will be your electric field. So, a dimensional formula, clear. So, now you can rewrite it as electric field due to the point charge, no. So, we already studied that Coulomb force, no. What is the formula here now? Therefore, K Q into Q by R square. Therefore, in this Q is taken here, no. Electric field due to the point charge, unit point charge, no. Therefore, you can write it as like A, force by charge onto this one, no. Therefore, K capital Q by R square. Therefore, K value is how much now? That is nothing but 1 by 4 pi epsilon naught into Q by R square, clear. So, this it will be your electric field formula due to the point charge. Electric field depends upon the source charge, that means who is creating the field, and electric field is inversely proportional to the square of the distance. Electric field is inversely proportional to the square of the distance. And electric field does not depend upon the test charge. Therefore, where you are keeping the test charge, no. So, therefore, it does not depend upon any test charge. It depends upon only source charge and the distance and the medium, that is all. So, therefore, how it will be depends, no, inversely proportional. So, this is a magnitude wise. Therefore, if it is right on, if you can write it in the vector form, no, therefore, electric field it will be equal to, therefore, 1 by 4 pi epsilon naught into Q by R square into in the R cap, R cap. So, that is unit vector, unit position vector, 1 by 4 pi epsilon naught into Q by R cube into R vector. So, this is your electric field formula in terms of vectors now, clear. Now, you can understand, you can get the doubt, no. Therefore, what is present inside this in this region, in the electric field region, no, what is present. So, and also you can get the doubt, no, how positive charge and positive charge they are getting repel each other, and positive charge and negative charge how they are getting attracting each other now. Therefore, and also how they are knowing that. So, therefore, what is present inside this field. So, these things we can be explained by using the electric field lines. Electric field lines. So, this was explained, these field lines are imaginary field lines, no. So, this is used to explain about electric field here now. So, therefore, these are some imaginary lines, so which is explain how these charges are going to experience a attraction and repulsion force and what is present inside the field, no. So, this can be explained by using these lines, no. If there is a charge is there, therefore, it is Q. So, therefore, this is your one region is there, no. This positive charge, no. Therefore, what happen now? It will be experiencing it contains like the field lines which are coming out from the positive charge now. Therefore, the field lines, the positive charge, what it will do now? It is going to emit the field lines in all the directions. Therefore, in the form of like a sphere of influence onto this. Suppose there is a negative charge is there, no, negative charge is there. What this negative charge will do now? Therefore, it will receive the field lines. That means, so this positive charge will act like a source. Positive charge will act like a source of your electric field lines. Negative charge will act like a sink. It will take the field lines onto this. Clear? So, here positive charge and negative charge can be developed separately. So, that is why this originating of our field lines can be explained by positive charge and negative charge now. Clear? So, now this is act like a source. So, positive charge will act like a source, right. This negative charge will act like a sink where it will take the field lines. Now, what will happen now? What we will do now here? Therefore, here positive charge, no. Suppose one positive charge is there, here negative charge is there, no. right? Suppose here positive charge and negative charge is there, no? How the field lines will be there now? The field lines which will be emitted by the positive charge, no? This, and it will going to enter into the negative charge, right? So these are the field lines which are emitted from the positive charge and it will be entering into the negative charge, right? So these are the field lines which are going to enter into this one, no? These are going to emit the field lines now. Clear? So therefore here what will happen now, whatever it is emitted, it is trying to take the maximum number of charges now. To take maximum charges now, they are going to experience a attraction force. They will be experiencing a, so the pressure, so which is moving towards each other. Similarly, so here if there is a positive charge is there now, and also here positive charge is there. So how the field lines will be there now? The field lines, so this is emitting the field lines now. So this also it is emitting the field lines. Therefore both the sources only is there now. Therefore both the field lines it is emitting here now. So therefore these field lines are emitting here. So the field lines are coming out, right? Here also the field lines are coming out here now. Clear? So the field lines are coming out onto this one, no? This also coming out, no? These field lines, like therefore what will happen now? This also emitting, this also emitting. So therefore exactly like a, suppose there is a two pipes are there. The pipe, through that pipe, no, the water is coming out, no? Another pipe, no, through that water is also coming out, no? Therefore if these two pipes, no, therefore when they are both are coming, water is coming out, no? If they kept closer, so what will happen now? They will never attract. They will be undergoing like a repulsion. Like that, this also emitting the field lines, no? This also emitting the field lines. So they are going to experience a outward force. So they will be experiencing a repulsion force now. Clear? Now, so we want to calculate, therefore what will be the direction of your electric field, no? So therefore there anywhere, therefore if you can keep one positive charge here, no? So in which direction is going to experience a force, no? In this direction is going to experience a force. So this it will be the direction of your electric field at that point. Or if you know the field lines, no, so there you can draw one tangent here, no, the tangent onto this one, no. So the tangent, this tangent, so right, this tangent will give us like a direction of your electric field lines which is drawn at this point now. Clear? So tangent which is drawn here now, or the positive charge where you are keeping now, in which direction a force is experiencing, so that it will be the direction of your electric field lines. And these field lines do not intersect now. That means there is no intersection here now. Therefore, so no intersection here now. Therefore, the field lines will never get intersected here now. If they intersected, what will happen now? There will be no proper particular direction of your electric field cannot be determined here now. So therefore, there is electric field lines do not intersect. Do not intersect now. Clear? And so these electric field lines will not form like a one more closed loops now. Therefore here it is not going to form like a closed loop like this. Therefore, so it will not form like a closed loops. So therefore do not form closed loops. You are understanding? So therefore here electric field line properties, no, and also suppose if there is a charge is there now. Therefore here this charge is there, no. If the charge is very larger, so if the charge is large, so therefore more number of field lines will be emitted. More number of field lines will be emitted. Therefore number of field lines which is emitted, it depends upon the amount of charge. If more charge is there, more number of field lines. Less charge is there, less number of field lines. Right? So can you tell me if 1 coulomb of charge, so 1 coulomb of charge is there, how many number of field lines will be emitted? Can you tell me? So if 1 coulomb of charge is there, no, therefore 1 coulomb of charge is there. So this it will emit a number of field lines that can be done by using the Gauss law. Therefore 1 coulomb of charge, right, emits. So 1 coulomb of charge emits Q by therefore epsilon naught number of field lines. If Q charge is there, Q charge is there. Therefore 1 coulomb means what? 1 by epsilon naught number of field lines emitted by 1 coulomb of charge. Clear? So 1 coulomb of charge will emit 1 by epsilon naught number of times, no? So that, I mean 1 by epsilon naught this value, so that many number of field lines will be emitted. Clear? So these are the slightly important properties of our electric field, no? And also one more point is there, whenever we, okay, we'll discuss this one. So therefore, now we'll see. So one more different field lines, no, properties now. Therefore, here suppose if the field lines are there like this parallel onto this one, no, this is a parallel one, no. So therefore, equally spaced onto this. Clear? So equally spaced. That means this side is positive, this side is negative. Clear? So right here the field lines are equally spaced. That means what is the direction here now? This side your direction of your electric field. Electric field direction. That means, so where it is started, therefore it will always starts at positive charge. Where it will reach now? Always it will reach us to the negative charge, right? So it is emitted from the positive charge and it is reaching to the negative charge now. Therefore, so the direction of your electric field is always from positive to negative. These all are equally spaced, no? Therefore, electric field it will be this, it will be a uniform electric field. So what is this one, no? Uniform, so electric field. So that means what, if you take it is one point here, no? So therefore at this point E1 and at this point it is E2, so electric field it will be the same, a uniform electric field here now. Clear? So therefore everywhere the electric field it will be the same. So if you take it as, therefore here like this, no, therefore some charges are there like this, there is a field is there. So this is your field. Clear? So how it is there now? Therefore it will be like a diverging here, no, diverging. Therefore, so can you tell me the direction here, no? This side is starting, no, this side is ending, this side is positive charge, here is negative charge. Therefore, if you take it here, no, this region and this region, at this point these field lines are more crowded here. That means in less, in a certain area more number of field lines are there, no? Suppose it is E1 and it is E2. So where more crowded is there, their electric field will be stronger. That means at this point electric field will be larger, at this point electric field will be lesser. That means, so this is said to be like a non-uniform electric field. That means this is non-uniform. Therefore, here this is uniform electric field. Clear? So in uniform electric field, suppose if you keep any one charge here now, suppose one charge we are going to keep it here. Therefore, one small positive charge, no, of mass m. Positive charge, based on the charge polarity also it will be different, no. So positive charge is there, this is positive charge. So what will happen now? The positive repulsion, positive and negative it will attract. Therefore, it is going to experience a force here. How much force is going to experience now? So electric field is equals to force per unit charge, no. Force it will be equal to Q times of your E. Clear? So therefore, force, electric force, it will be equal to Q times of E. So this force can be written as, mass times the acceleration here now, right? So here why? Therefore here everywhere the electric field was same. So therefore you can rewrite it as mass times of acceleration. So is equals to Q times of E. A uniform acceleration is created, QE by therefore M. So this is an acceleration which is uniform now, constant everywhere onto this. So therefore you can use all the equations. Now what are the equations? V is equals to U plus AT. So S is equals to UT plus half AT square. So therefore V square minus U square is equals to 2AS. In this way you can use whatever this one, no? Therefore here velocity after certain distance, distance travelled in some time. So velocity after certain time, no? What is, right? This acceleration here you need to use this one. Clear? So these all the equations you can calculate it, no? Then you can right, you can use as per your equation which is required onto this. So one sample one now we will do it, no? Suppose there is in a uniform electric field, there is one uniform electric field is there. This is one uniform electric field, right? So a uniform electric field is there now. Therefore here electric field was how much now? It is E. This side is positive, this side is negative. Suppose there is a one charge is there, its mass is m, initially started from rest, therefore U is equal to 0. So we want to calculate what will be the kinetic energy after certain time t. Therefore we have to calculate kinetic energy So therefore after time t, what you can write in kinetic energy half mv square. So initial velocity is how much now? 0. Therefore final velocity what you can write in now? V is equals to u plus at. So u was 0. Therefore v is equals to qe by m into t. So can substitute it now. Therefore 1 by 2 m into therefore qe into t by m whole square. Clear? So therefore 1 by 2 m into q square e square t square by m square. Get cancel out now. So therefore q square e square t square by 2m. This it will be the kinetic energy after certain time t. Like this any equations no, therefore you can calculate it as per your given condition onto this. Clear? Suppose in what will be the direction here now? In this direction is going to experience, right? Suppose negative charge is there no, it will be experiencing toward this direction onto this. Clear? So therefore if you are giving the velocity in this direction, so also force is acting in the same direction, therefore velocity will increase. Suppose if you are giving negative charge no, in this direction, so therefore it will be experiencing force in the opposite direction, creates retardation, the speed it will becomes to the 0 onto this. Understood no? So therefore here one more application also we can rewrite no. Suppose there is a one plates are there, this is one plate no, these are the one positively charged plate, right? So this is your negatively charged plate. So here these plates no, therefore it is going to emit the electric field lines no. So how the field lines will be there? These field lines it will be the uniform. Here there will be one edge effect will be there. This edge effect can be neglected here now. Therefore here there is a edge effect is there no, we are going to neglect it. So we can calculate the electric field at this point no. Therefore electric field, if we know the potential difference no, therefore V by D. So therefore here electric field also we can calculate if there is a potential difference between the two plates. Now this it will be your electric field lines no, like this. So all everywhere it will be the uniform no, electric field lines no. In this one now, therefore there is a one a drop it is there. This is one drop, oil drop. Therefore it is having some mass m, it is having charge q. If this drop, therefore it is at rest, it is at rest, other it is under equilibrium or falling downward with a constant speed onto this. So therefore charge should be positive or negative. So first of all you have to therefore you have to equate the forces no, downward force is how much no, that is mg, and compulsory to balance this because it is under equilibrium. Equilibrium means what? Therefore net force it will be equal to 0 here. So downward force is there, definitely there will be a upward force is required, that is nothing but a q times of your E. Clear? So if you know the electric field here no, you can calculate how much charge is there no, therefore mg it will be equal to q times of E. Sometimes they will ask how many number of charges are there, positive charge or negative charge. So here this direction of your electric field is there, compulsory this side is experiencing means compulsory negative charge. Negative charge means what? Negative charge means more number of electrons. How many number of electrons are present, like that also they may ask you. So whatever the condition is there no, therefore you can use it. So here q is equals to therefore Ne, so therefore mg is equals to Ne into E. So therefore here number of electrons can be calculated, so based on the direction of your electric field. You understand no? Clear? So in this way you can calculate mass. Sometimes they will ask the radius. What is the radius here now? Mass is equals to density into volume. So mass is equals to density into therefore 4 by 3 pi r cube. So this it will be your mass is equals to density into volume. Therefore you can substitute it, you can solve it as per your given questions onto this. Sometimes, so suppose here sometimes what is given now, some questions no, if they reverse this electric field, what we will do now? So this downward force it will be there onto this one no, and also this this electric field, that is weight and electric field force no, both it will act in the downward force no, acceleration will be larger, so that it will come down very very quickly. Clear? So that type of questions also, one numerical questions no, we will do it onto this. Clear? So now we can use this same concept no. Suppose here there is a some electric field and therefore here the charged plates are there. Now this is a positively charged plate no. Therefore, here it is negatively charged plate. So, in between this one, these type of questions mostly they are asking, no. So, in this one, no, there will be a one bob is there, bob of mass m and length is l. So, what about the time period? So, initial time period is how much now? Time period it will be equal to 2 pi into square root of L by G. That means time period is inversely proportional to square root of G. So, therefore, now what happened now? Now this electric field is there, it is having some charge Q. So, therefore, here when it is comes here now, what will be the net force here now? Downward force is mg. So, and also suppose there is a positive charge is given, no, positive charge. So, this side it will be your electric field lines. Therefore, downward only, therefore, Q times of your E. So, what will be the net force here now? Net force it will be equal to, therefore, mg plus QE. So, therefore, net acceleration, no, therefore, A effective. So, A effective acceleration divided by m g plus QE by, therefore, m. Clear? Right? So, here now downward acceleration it will be there. So, time period, what is the time period now? 2 pi into square root of L by, therefore, G effective, no, that is nothing but a G plus QE by, therefore, M. This it will be the time period if it is given as a positive charge. Suppose it is given as negative charge, what will happen now? So, it is experiencing an upward force, no, you are going to get it as minus here. Clear? So, in this way you need to calculate the time period. What will happen now? Time period now, this A effective it is increased, acceleration effective is increased. So, time period will decrease. Time period decrease means it will able to do very quickly onto this. So, therefore, frequency will be increases. Clear? Right? So, one more application we can do it now. Suppose here there will be a one pendulum is there now, this one pendulum. Therefore, it is having mass m, having charge q. So, therefore, this side it will be your electric field is applied here now. Electric field is applied here. What will happen now? Electric field here. So, therefore, when it is comes to here now, so what will be the direction here now? Downward force is nothing but a, so this is G and this side is a force experience. Therefore, positive and negative. Suppose positive charge it is given onto this QE by, therefore, M. What will be the effective acceleration here now? Therefore, here now root of, therefore, G square plus QE by M whole square. Therefore, what will be the time period now? Time period is equals to 2 pi into square root of L by, therefore, again root of G square plus QE by M whole square. So, this it will be a time period. So, if the electric field is applied in this direction now. So, here also we will do one question here now. Suppose if the electric field is applied in this direction now, therefore, what will be the angle? Therefore, it is making an angle theta. So, he is asking what will be the tension here now. This one now, we can do one more problem. So, if it is having an angle theta here now, we need to calculate the tension which is acting in this one now. So, what is the tension here now? Therefore, here you can rewrite it as, so therefore, this is theta means this also theta. So, therefore, here this is what you can write it now, this side it will be the T cos theta and this side it will be the T sin theta. Clear? So, here we can rewrite it as tension here no. Therefore, here T sin theta is balancing that force. Actually, this side you should get it as force no. So, force how much it will be now? Q times of E. So, this times of mg. Q times of E and T cos theta is equals to mg. This will take it out onto this one. No? Therefore, tan theta it will be equal to QE by, therefore, mg. So, theta is equals to, therefore, tan inverse of QE by, therefore, mg. Clear? So, in this way you can calculate the tension, right? Also angle also, tension, okay, this is an angle. Tension means what you do know, therefore, so T sin T, square it and add it, T cos theta whole square is equals to QE whole square plus mg whole square. Clear? So, therefore, T is equals to root of QE whole square plus mg whole square. Clear? Clear? So, in this way you can solve the tension in this one. Clear? Now, so one more concept, no? Suppose here there is an electric field is there, no? Therefore, here suppose here there is a positively charged, right, plate here, no? Right, here it will be the negatively charged plate. So what will be the electric field here now? Downward direction will be your electric field here. Clear? So in this way the electric field direction is like this. So now what you are going to do now, therefore we are going to project one charge here, no? Therefore one charge of mass m, positive charge, no? We are going to project with a horizontally with one speed, it will be L. Now what will happen now? This charge, no? So when it is going, when it is projected with one speed here, no? Therefore what will happen now? Here when it is entered into this one, no? This side speed is there. Therefore downward one, it will be the forces acting onto this. What is the downward force now? That is nothing but a mg, and not only mg, therefore it is having positive charge, no? Therefore it will be having the q times of your e. And downward acceleration it is given as like a g plus qe by therefore m. This is your downward acceleration, no? So therefore what is going to happen now? This charged particle, no, it will be able to go like this. Therefore here, so here this is your, this is exactly looks like a horizontal projection onto this. Clear? Horizontal projection means what? So therefore you know it, no? Here if you want to calculate the velocity, therefore you need to draw a tangent here, no? This is your velocity. So this side it will be your vx and this side it will be your vy. So horizontally there is no other forces acting, no? So horizontal velocity it will be nothing but u only. But downward force is there, no? Downward velocity, so it is because of due to the this downward force, no? Initially it is given a velocity along this downward direction is 0, so but it is going with an acceleration, no? You can rewrite it as therefore vy, so suppose after some time t, so therefore uy plus ay into t. So this horizontally we are provided, but downward velocity we did not provide. So initially there is no downward velocity after this. So therefore vy is equals to ay is nothing but how much now? G plus qe by m into t. So this it will be your vy. So what will be the velocity vector here now? Velocity vector is nothing but a u horizontally. So therefore it is I cap. So plus v, therefore g plus qe by m into t, therefore j cap, that is downward, no? Therefore minus j cap. You can rewrite it as minus j cap. This it will be your velocity, so at any point onto this. Therefore they may ask you what will be the distance, horizontal one now, time taken to reach, all this one. If they know height of this one, no, exactly horizontal projectile motion, no. So what will be the time taken here now? So time taken to reach down. So time, what is the time now? Formula 2 into h by g, but g is what? This one now. Therefore g plus qe by m, the time taken to, suppose this is your height is h. Suppose it is projected from this height, no, the time taken to hit down. So this it will be your formula. So what it will be a range now? At what distance it is going to hit it, no? So that is nothing but a range. So is nothing but a u into therefore t. So this is your range, horizontal distance onto this. Clear? So therefore this is like a horizontal projectile motion, no? So even instead of time, no, you can calculate in terms of displacement also, you can calculate it now. Clear? Now, so the same type of question, no, suppose here there will be a one positively charged plate is there, no, this one positively charged plate. So here it will be the negatively charged plate here, no. So therefore the electric field it will be, how the electric field will be there? In this direction. This is your electric field direction now. Clear? So now what we are going to do now? Therefore suppose here we are going to project one particle, no, therefore q of mass m, you are going to project with a velocity is u. So we are going to, therefore here we are going to make it like an angle theta here, no. So this it will be nothing but a u cos theta, therefore u sin theta. So what will happen now? This it will go like this. So therefore what will be the downward force now? Downward force acceleration nothing but a g plus qe by m. This is your downward acceleration onto this one, no. So therefore we know that what will be the time time of light. What is the time of light now? Time of light is nothing but 2u sin theta by g. 2u sin theta by g. G is nothing but g plus qe by m. So based on this one now, therefore direction also. Suppose negative charge is given now, so you would have written as g minus qe by m, right? So time, okay. So range, what is the formula? U square. So sin 2 theta by g. G is nothing but g plus qe by m. So maximum height now u square. So sin square theta by 2 into g plus qe by m. Therefore you can rewrite it as maximum height. All this one now, right? So you can calculate it now. Understand now? So therefore if it is positive charge, that's why this mg is their downward direction, and qe by therefore m, therefore it is g downward direction. Clear? In this way, so you can calculate all these problems onto this. Understand no? So now we'll do some numerical questions onto this one, no, which are related to this one. And also therefore here the field lines, okay. So we can when I am discussing about the conductors, no, therefore at that time right, we will discuss the field lines. Therefore like potential is there, no. So across the conductor, if there is a conductor is there, so here one point is there, no. So we can take it here, okay. So in this one, no, actually I thought of discussing right, when I am discussing about the potential, but here if there is a one metal is there, there is a one metal. So suppose this is one metal is there, this is one metal. What will happen now? Therefore this metal, no, for this metal nothing but a conductor. Suppose if you are giving the charge at any point here, no, if you are giving the charge here, no, this charge automatically it will be get distributed on the surface of this one, no. That means what will happen now? Therefore here, so if you are giving any charge, no, the charge automatically it will be get distributed only on the surface of this. Clear? Huh? So therefore here, right. So therefore the charge it will be able to distribute only on the surface. What will be the charge inside this one now? The charge inside the metal it will be the 0. What will be the electric field inside this one now? Electric field inside this one will be 0. So what about the potential? Potential will be constant, no. That I will discuss when I am discussing about the potential, right. Electric field will be 0 inside the metal onto this. The charge which will be only accumulated only on the surface. Now suppose here, therefore how the electric field lines will be coming now? The field lines will come out, so which is perpendicular to the electric field lines now. Therefore I mean these field lines, electric field lines which will be always emitted perpendicular to the surface. Therefore you have to draw a tangent here, no. The electric field lines will be emitted perpendicular to the surface. Here you have to draw. Therefore this electric field line is possible? No, not possible. Why? Because there is no perpendicularity condition here now. Whether some field lines are coming like this, no. Therefore here it is possible? No, because it is not perpendicular to this one now. Therefore here the field lines are coming out now. Is possible? Yes. Therefore it is perpendicularity to this one. Therefore always electric field lines will be emitted perpendicular to the surface onto this. That is most important, no. So this theta is equals to 90 degrees. This is one of your NEET question, right. So electric field lines will be emitted perpendicular to the surface of this one. Therefore there is no charge will be accumulated inside the metal onto this. Therefore electric field inside the metal body it will be always 0. Clear? Right. Here I will discuss the calculation of the electric field. So let us see here, no, there is a one point charge, electric field, right, electric field due to point charge, no, point charge, very simple one, no. Suppose there is a 10 microcoulomb, therefore there is a one charge is there, no. So we want to calculate the electric field. So at certain distance r is equals to 10 centimeter. Therefore at this point what you have to do? You have to assume plus 1 coulomb, right. So plus 1 coulomb, what will happen now? Therefore here this is a positive charge, no, positive charge, no. What will happen now? It will undergo like a repulsion force. This it will be a direction of your electric field. What is the formula? So kq by r square. What is the k now? 9 into 10 to the power of 9 into q is how much now? 10 into 10 the power of minus 6 by r square means 10 the power of minus 1 whole square, 10 the power of minus 2. Therefore, how much it will be taken here now? 9 into 10 the power of 9 into 10 the power of 3 into 10 the power of minus 6. How much it will be now? So, therefore, here it is minus 3. Therefore, here 9 minus 3 is nothing but 6. 9 into 10 the power of 6. Therefore, Newton per Coulomb. Clear? So, suppose if there is a negative charge is there now, therefore, it will be experiencing a toward this direction now. Suppose here there will be like some charges are there now. Suppose here there is one charge is there now. Therefore, here also there is one more charge is there. The distance is L. So, therefore, we want to calculate the electric field at this point now. Therefore, this distance is L, this distance is L. That is nothing but equilateral triangle. What you have to do? Therefore, there wherever you want to calculate at this point P, no, you have to assume plus 1 Coulomb, right? Plus 1 Coulomb. This is Q, positive charge, no, positive charge. What will happen now? It is going to experience a force here, no, this direction now. This is the direction of your electric field. That is nothing but K into Q by L square. This also experiencing toward this side KQ by L square. What is the angle between them now? 60 degree. This also 60 degree. Both are same, no. Therefore, it will be root 3 KQ by L square. Therefore, electric field at point P, therefore 1 by 4 pi epsilon naught into therefore root 3 Q by L square. So, this it will be your electric field at point P now. Suppose similarly there is some charges are there now. This is plus Q, right? Now this is also plus Q. So, therefore, this is minus Q and this it will be the minus Q. Therefore, we want to calculate the electric field at this point, at the center of this one. So, therefore, here at the center, no, therefore, there we have to consider plus 1 Coulomb, no. So, what will happen now? This is your positive charge, this is also positive charge. So, therefore, here what will happen now? They are going to undergo like a repulsion force. Clear? So, this it will be distance is L, therefore, L by root 2. So, this is toward this side, this is negative and positive, this also toward this side, and this positive, therefore, repulsion toward this side, this one also it will be attraction toward this side. Therefore, due to this charge, no, this is E and E, therefore, 2E, so this also 2E. Clear? So, what will be the angle between them now? Therefore, this angle between them is 90 degree. So, therefore, resultant it will be equal to root 2, therefore, into 2E. So, electric field at center of this one, no, what will happen now? Root 2 into 2 times of E, that means 1 by 4 pi epsilon naught into Q by, therefore, L by root 2. Therefore, what will get it now? This root 2 into root 2, 2 into 2, 4. Therefore, this 2 get cancelled out now. Q by pi epsilon naught into L. This it will be your electric field. Clear? Now, so here exactly how we written like a Coulombian force, no. So, like that only exactly we can able to do it. So, the problems, but here you have to assume at any one point wherever you want to calculate, no, there you have to assume plus 1 Coulomb. That's all. Rest of everything it will be the same. But one important point we are going to take it, no, very important point, most important point. Suppose here there is a two identical charges are there, identical charges, no, they are separated by some distances r. So, at midpoint, therefore, what will be the electric field? Plus 1 Coulomb. This side it will be the repulsion, this side it will be the repulsion. Electric field at the midpoint it will be equal to 0. Suppose here the charges are there, no, these charges, so which are corners of your equilateral triangle, no. Therefore, what will be the electric field at the center, no? Also electric field at the center it will be the 0. Suppose here the charges are then Q and Q, therefore, here it is Q and here it will be the Q. All are identical charges arranged in a geometrical pattern. Therefore, at geometrical center, therefore, the electric field it will be the, so at the geometrical center electric field it will be the 0. All uniform charges, no, arranged at the corners of any geometrical pattern at the geometrical center. So, therefore, the electric field will be always 0. right? So this point is very, very important, no? So electric field will be 0. So at here electric field will be 0 for if a uniform identical charges are arranged at the geometrical pattern. At geometrical center always electric field will be 0. We can use this concept now to solve some type of problem. Suppose there is a one charge is there, no? This one charge. So these charges are kept at corners of a one regular pentagon. So these charges are kept at corners of a regular pentagon. This is your R and R. Sorry, this distance are not required now for us, no? Now, so this is a pentagon, no? Therefore, pentagon of all the sides are same, no? So at the geometrical center, can you tell me what will be the electric field, no? First one, these are a regular geometrical pattern, no? So, right, actually pentagon will not be like this, no? Let us see here, no? We will see the pentagon, regular pentagon. Right. So here at the geometrical center, therefore electric field, right, at the center it will be equal to 0. Electric field will be 0 at the geometrical center. So where it is a distance is r from this one. Now suppose, right, so now next question is what, see here, very important, no, the second question, no, if one charge is removed, if one charge is removed, what will be the electric field at this point? So let us write down. So direction also A, B, C, D, E. So this is O. What will be the electric, if a charge is removed onto this one now? If it is removed means what will happen now? Therefore here there is a no charge is there now. So what you can rewrite it as now? Therefore here it will be the plus Q, I can write it now, minus Q I can write it now. So due to plus Q, what will happen now? The electric field will be 0. So when it is removed, therefore the electric field it will be generated. So due to the minus Q at that point, no, that means it is minus Q at that distance, no. So the electric field will be at this point. So that means electric field this plus 1, no, it will be toward this direction. That means electric field it will be in the direction of O to B. Therefore what will be the electric field, no? 1 by 4 pi epsilon naught into Q by R square along OB towards this direction. Okay. So one more question can be written now, one more question can be added in this one only. Suppose if any one of the charge is there, no, it will be replaced by, suppose any one of the charge, no, so it is replaced by negative charge, right. So now let us see now, here there is a again regular hexagon is there, no, suppose here there is a charge is there. So this is one charge, so this is charge, right. Suppose assume that, so this is your regular hexagon, no, assume it. Right, assume that. So therefore one charge what you are going to do now, therefore this is A, B, C, D, E. Therefore assume that this charge was replaced by negative charge. So how to solve this type of problems now? That means it is replaced by negative charge means what will happen now? Therefore it will be, now it will become like a minus Q it is. Clear? Minus Q means what? Therefore you can rewrite it as minus Q means, so I can write it as plus Q and minus Q. Can I write it now? So therefore this plus Q, plus Q, plus Q, plus Q and plus Q, electric field will be 0. But here still how much charge it will be pending now? Minus 2Q. That means, so electric field at this point now, so it is nothing but a minus 2Q at the point it is R. So we want to calculate, this is A, suppose, therefore it will be act along the OA. So how much it will be now? 1 by 4 pi epsilon naught into 2Q by R square along OA will be your electric field. Understood? In this way you can solve the problems very, very easily. So using this concept now, right? So most of the times now the complicated one now, these type of questions, right, we can solve it very easily by knowing this point. So if it is all are same charges, geometrical center, so electric field will be 0. If it is one is replaced, it is removed, means so it will be equal into the minus q at that point. If it is replaced by minus q means what? So therefore it is nothing but a electric field due to the distance of minus 2q at that point now. Clear? So in this way you can calculate the electric field due to the distribution of the charges now, right? So we will see some more questions now, some numerical problems now, we will do it based on this electric field concept now. Clear? Right students, we will solve some problems now based on this one now. Let us see, okay, this a charge of 10 microcoulomb and minus 10 microcoulomb placed in a electric field is there. There is a uniform electric field is given, no, lies along the x-axis. Find out the force. So that means along the x-axis there is an electric field is there, uniform now, right? How much electric field is there? 5 into 10 to the power of 6, right? If it is a one positive charge is kept down, therefore positive charge same, no. What will happen now? It is going to experience a force in the direction of your x-axis. Force, it will be equal to q times of your E. Q is how much now? 10. 10 into 10 to the power of minus 6. Electric field is nothing but 5 into 10 to the power of minus plus 6. So this will cancel now. Therefore 50 Newton per coulomb in I cap. So same 10 to the minus 10 coulomb now. Therefore it will be acting in the opposite direction now. So second question now. Therefore minus 50, right? So in I cap. So Newton per coulomb. Or actually 50 into minus I cap actually. It will act in the negative direction here now. Clear? So now let us see one more question here now. Right. So here just now we discussed, no, calculate the electric field intensity which would just sufficient to balance the weight of a particle of charge is given now. Therefore here, so weight of this particle is how much now? So what is the mass of this one now? Therefore it will be mg. So compulsory it should exert the force onto this one now. F is equals to q times of E. So this is negative charge means compulsory. So it should be exert the electric field in this direction. Sorry, here no. So it should experience in this direction now. Right? Electric field. Sorry, here in this one no. Electric field should be in this direction. Right? So this side negative. Therefore negative means it is going to experience an upward. In this way you have to exert the electric field. No. So we want to calculate electric field. Q times of E is equals to mg. E is equals to mg by q. M is how much now? 10 microgram. Very important. 10 micro means 10 to the power of minus 6 grams. Grams means 10 to the power of minus 3 kg into 10. So by charge is how much now? 10 microcoulomb, 10 to the power of minus 6. Get cancel out now. So 10 to the power of minus 2 Newton per coulomb. So vertically downward direction. Right? So it will exert the field in the downward direction now. Clear? Now let us see one more concept now. Here one more problem. Right. A positively charged oil drop is there now. So it is in the uniform electric field. Suddenly the direction of electric field is reversed. What will be the acceleration of the drop? So initially there is a drop is there, no. Therefore what happened now? Downward force is nothing but a, so mg, and upward force is nothing but a F is equals to q times of E. Now what happened now? Now the direction is reversed. So therefore what will happen now? This it will be the mg and it will be nothing but a q times of your E. So what is this? Q times of E is nothing but a mg. Clear? So total downward force it will be equal to how much now? mg plus q times of E. Q times of E both are equal now. Therefore 2 times of your mg. So therefore here what will be the acceleration of this one now? This is nothing but a ma. Get cancel out now. Acceleration is equals to 2g. Clear? So 2g will be your acceleration on this. Clear? Now Let us see one more question. No? Okay. So a charged particle is there kept at the origin now. So where is the charged particle is there now? At the origin here now. Therefore, here what is the charge here now? 1 microcoulomb, 10 to the power of minus 6 coulomb. Clear? So kept at the origin. We want to calculate electric field at certain point here now. Therefore, this it is nothing but 3, 4. What will be your position vector here now? What will be the position vector? R vector is equals to 3i plus 4j. Clear? So what is the magnitude of this one now? Magnitude is nothing but so root of 3 square plus 4 square, that is nothing but 5. Clear? Electric field is how much now? Therefore K is nothing but 9 in, okay, we will write it as that equation now. So here K into Q by R square or R cube, right? R cube in R vector here. Clear? In this way we can calculate it now. So here 9 into 10 to the power of 9 into what is the charge here now? Microcoulomb 10 to the power of minus 6 by R cube means nothing but 5 cube into therefore 3i plus 4j. So how much it will be now? 9 into 10 to the power of 3. So that means 10 into 10 into 10 divided by 5 into 5 into 5. So therefore 3i plus 4j. So 2 times, 2 times, 2 times. So 8 9s are 72 into 3i plus 4j. So this it will be your electric field at that point. Clear? Now let us see one more question here now. Right. Electric field at the origin due to the infinite number of charges shown in A and B. I will tell you A, therefore you can do it as a B, no. So very easily you can calculate no electric field. So these all are same charges, no. This is plus, that means it is repulsion, 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 no. So what will be the electric field at O? It is due to E1 plus E2 plus E3 infinite up to infinite. So what you will get it now? K into Q by 1 square, this distance is 1 square, K into Q by 2 square, K into Q by 4 square, so on up to infinity. K into Q by 1 by 1 square plus 1 by 2 square plus 1 by 4 square plus so on. How it will be? So you can do the ratio of this one, no? 1 by 4, that 1 by 2 square by 1 by 1 square. So here 2 square, no, 1 by 4 it will be there. So you can rewrite it as 1 by 4 square, 1 by 2 square. So how much now? 1 by 4 into 4 into 2 into 2 get cancelled out, no. Therefore again 1 by 4 here now. So that means this all is in the GP. So this is sum of the infinite terms, no. So what is the sum of the infinite terms now? Electric field at this point, no, KQ into what is the sum of the infinite terms now? First term by A by 1 minus R. Yes, and first term is how much now? So first term is nothing but 1 by 1 minus 1 by 4. So how much it will be? So this it will be 3 by 4, that means 4 by 3. So this it will be the 4 by 3. 4 K Q by 3. So will be your electric field at this point. Clear? So now in this situation now, here first one is positive, this one is negative toward this side. I mean sorry here no, this side it will be the toward this side and this side it will be I cap and minus I cap. This is minus I cap, this is plus I cap. So you can rewrite it as R, you can take it as this side positive, negative, no. Then you can rewrite it as 1A by 1 plus R. So then you can get it as very easily about this one. That means A by 1 plus R means 5, therefore 4 by 5. So 4 by 5 KQ will be your answer in that. Clear? So you can try it. If you don't understand, no, please just comment it, no. Therefore again we'll solve it. Right. This is one confusion question, no. Most of the students know they will get confused. This is a simple question only, but it will be slightly confusion. No? So what are there are two different points on the surroundings of a point charge at same distance. That means there is a one point charge is there, no? Point charge is there. So these are your electric field lines. Right. These are your electric field lines. Now what is asking now at the same distance? That means this is your same distance, no? So here at this point A is there, at point B is there. So will the electric field is same or not? Right? So most of the students know what they will tell. So electric field magnitude is how much now? KQ by R square. So same charge, same this one, no? Magnitude is same. Magnitude is same, but electric field is a direction onto this one now. Therefore, along this one now electric field is in this direction now. Along this one now electric field is in this direction now. Direction is different. So magnitude is same, direction is different. Therefore, electric field is a vector quantity. So therefore, electric fields are different. Clear? Huh? So therefore, electric field, those point it will be the same, is a false statement. Clear? So next one. Here I will add one more question here also. Let us see this one. No? Simple question this one. No? Here. Now tell me this Q1 and Q2 is there, which is positive and which is negative. So field lines which will emit, no, that is said to be positive. That means here field lines are emitted, this is positive. Q1 is positive and Q2 entering, no, Q2 is negative. Therefore Q2 is negative. Clear? So Q1 is positive, Q2 is negative. This statement is correct. But one more statement is also is there, where therefore this Q1 is having large number of field lines onto this one, no? This Q2 is having less number of field lines, 1, 2, 3, 4, 5, 6, 7. 7 are there. But here, so 3, 6, 9 are there. That means, so Q1 will be larger than Q2. Therefore, first and third options are correct one. Right. In this one now, one more question I will add it now. Suppose there is a one charge is there now. Therefore, suppose it is Q3 charge is there. So what happens now? Q3 charge now. Therefore, the field lines it will be emitted like this. This is we can call it as like a this is at Q1, Q2, Q3. Okay. Right. So therefore, can you tell me Q3 is positive or negative? Just now I told no. Q3 is positive because it is emitting the field lines. Can you tell me, so where the electric field will be 0? In between Q1 and Q2 or Q2 and Q3 or Q1 and Q3? So where, what is the question now? Question is what? So where the electric field will be 0? Electric field will be 0. In between what? So in between this one now. Or we will test it now. How to, right? So suppose I will take 1 plus 1 coulomb. This is how much now? This it will be repulsion now, this attraction now. Therefore, here electric field will not be 0. So in between this one now, I will assume plus 1 coulomb. This is negative. So attraction now, this is positive, repulsion now. Therefore, here also not possible. So in between this one now, I will apply plus 1 coulomb. So this is repulsion now. Therefore, this also it will be repulsion now. Therefore, electric field will be 0. So in between, so Q1 and Q3. Clear? So in this way also you can expect the questions onto this. Let us see this one now. Therefore, the lines of force looks like. So here the field lines, this uncharged metal sphere, metal is there, no? So field lines will not pass through this one, no? Therefore this is wrong. So here, okay, the field lines are coming here, no? Therefore this is negative charge, no? Therefore this is positive charge. But here perpendicularity is missing here, no? Therefore this is not possible. So here we can draw it now, so that what will happen now? Here, so this is one metal, no? This is positively charged. Positively charged means what will happen now? This will become like a negatively charged one now. So this is negatively charged here, no? This will become like a positively charged. Clear? So what will happen now? Here the electric field lines. So here it will be emitted and it will be entered. So but perpendicularly here now. Therefore here perpendicularly. Clear? So this is right. So here, right. So these are your electric field lines. Therefore, so best possible one is nothing but this C. Clear? Now let us see this concept. No, these are the some charges are there here. No, placed at the corners of this one. Find the direction of your electric field at the center of the square. No, so therefore here what will be the direction here now? If you want to calculate, therefore plus 1 coulomb you have to assume. No, plus 1 coulomb means what will happen now? This 4q. So therefore here it will be the 4e. So due to this one now, therefore 2e. Correct? So this is due to this one is 3e. This distance is nothing but e. Therefore totally what will be the electric field at this point now? This 2e and 4e. So therefore it will be 2e, it will be there now. So this side 3e and this side it will be the, so again 2e. Clear? So this it will be the 2e. So this is downward here now. Therefore root 2 into 2e. So downward. E 3. So it is in this direction now. Direction means what, like a CB direction onto this. Clear? So therefore this is downward direction which is parallel to this CB. So parallel to therefore CB direction. Clear? Now let us see this one now. There are two charges are there placed at a part now. Find the electric field at the midpoint. Yeah. So let us see simple question here now. So here 5 microcoulomb is there, and this is separated by therefore 10 microcoulomb. So 20 centimeter means midpoint now, 10 centimeter into 10 centimeter. Clear? So what will happen now here? So therefore here plus 1 coulomb you have to assume now. When plus 1 coulomb is assumed, so what will happen now? This it will be undergo like repulsion here now. Therefore this is due to E1 and E2. So this charge is more, E2 is greater, therefore net electric field is toward this side. So net electric field is toward the plus 5 coulomb, right? So either first option or third option should be your answer now, directed towards. So you can write it as E is equals to E2 minus E1. How much it will be? Only charges are different. Medium is same and distance is same, no? Therefore K by therefore R square into charge of this one now. Therefore charge of this how much now? It will be E2 is nothing but because of due to 10 minus 5 into 10 to the power of minus 6. Then what you can get it now? K value is nothing but 9 into 10 to the power of 9 divided into 5 into 10 to the power of minus 6. So 10 centimeter, 10 to the power of minus 1 whole square means minus 2. So taken top here now, therefore it will be 4. So plus 2 minus 4, therefore 5, 9 5s are 45. So this is 45 into 10 to the power of, so 5 Newton per coulomb. Right, 45 into 10 to the power of 5 means 4.5 into 10 to the power of 6. So first option will be a correct answer now. Right students, we'll do one more question here. Right, an electron is there, right? An electron is moving with a speed of 5 into 10 to the power of 6 meters per second, should parallel to this one now. Suppose, let us see in the physics now, therefore you should read the question, then afterwards you should analyze that question, right? So what is this is given now? There is an electric field is given now. So this is one uniform electric field is given. Electric field is given. That means this side it is positive, this side it is negative. Now what happened now? If within this field now, therefore electron is shooted now. Therefore electron is shooted with certain speed onto this, right? So shooted parallel to the electric field. Electric field is given here, right? So 1000 Newton per coulomb. So the field is responsible for retardation. See, electron is going toward this side means, so it is experiencing a force in this direction now. Clear? So definitely retardation will create. No, evaluate the distance traveled by the electron before coming to the rest. That means it will come here, no, somewhere distance here, somewhere distance it will travel, so that final velocity will becomes to the 0. You understand? We have to calculate the distance. First of all, you should go for acceleration here, no. So first, therefore, you know that force is acting onto this one now, E into E. So therefore, here force is equals to mass into acceleration. Acceleration is equals to E into E by M. So this acceleration means is acting in opposite direction, means retardation now. So therefore, E, what is the charge of the electron now? We know it 1.6 into 10 the power of minus 19. Electric field is nothing but 1000 divided by mass of the electron is nothing but 9 into 10 the power of minus 31 it is given. So how much it will be now? Taken top now here. So 1.6 divided by 9 into 10 to the power of 34. 34 minus 19. Clear? So 19 means here it will be 1 means 20, so 14, 15. So 1.6 or 16 by 90 into 10 to the power of 15 it will be there, no? Or so 16 by 9. So 16 by 9 into 10 to the power of 14. So will be your retardation here now. So very huge. Clear? So meter per second, right? Now we want to calculate the distance traveled onto this one, no? So distance traveled, therefore here what we can write right now? So v square minus u square is equals to 2as. So what will be the velocity which is projected here now? What will be the velocity here now? 5 into 10 the power of 6 meters per second, right? So therefore here what will be your initial velocity here now? So final velocity was 0, initial velocity nothing but 5 into 10 the power of 6 whole square, it will be equal to 2 into acceleration, it will be equal to, that is 16, retardation is equals to 16 into 10 the power of 14 into s. Clear? So therefore here what you can write it now? Therefore here it will be 25 into 10 the power of 12, it will be equal to, therefore 2 into 16 by 9 into 10 the power of 14. So into s, this minus and minus get cancelled out, no? So therefore you can rewrite, you can simplify this one, no? Right? So s is equals to, so taken here, no, 25 into 9 by 2 into 16. So into 10 to the power of 12 divided by this one means 10 to the power of minus 2. So will be your, right, simplified form now, right? So 25 into 9 to 9, 225. Right. So nearly 7 you will get it now, 7 into 10 the power of minus 2 meters, or 7 centimeter, nearly 7 centimeter will be your answer. Clear? Right? So 7 centimeter it will be your answer on this. So in this way you can solve the problems like this, no? So let us go for one more question here, no? Right. Now an oil drop is there, oil drop of having 10 excess electrons. So it is having 10 excess electrons, is held stationary under the constant electric field in the Milcon's oil drop experiment. The density of the oil is given, radius of the oil is given, no? So we want to calculate radius of the oil drop. So what is given now? It is having excess of electrons. Excess of electrons means what? Negative charge. So definitely, so this oil drop is there now, therefore definitely it is going to experience one force, no? That is nothing but a mg. So this side it should experience a force, no? That is nothing but a E into E. So if you exert the force in this direction, no? Therefore how the electric field should be there? Electric field should be in this direction now. Why? This is having a negative charge here, no? Therefore this side positive, negative. So it is going to experience a force in this direction now. So these two are balancing onto this one, no? Therefore we want to calculate the radius of the radius of the oil drop now. Therefore, what is the charge here now? Therefore, these two are balancing now. So, you can write it as mg is equals to therefore E into E. What is the charge on this one now? Charge on this one now Q into E, actually Q into E. Therefore, M is nothing but a 4 by 3 pi r cube into G. Q is nothing but a number of electrons into charge of the electron into the electric field. Electric field is also given onto this. So, R value we can't write, we want to write it now. So, R cube is equals to, so therefore, N into E, therefore 3 divided by 4 pi into G. R is equals to 3 into N into E by 4 pi G whole to the power of 1 by 3, right. So, 3 already constant, no, number of electrons is nothing but 10, charge of the electron you know it now, electric field already is given onto this one, no? 4 pi into G value is also 9.8. So, please substitute it. This is just, it will go for right more numerical part of this one, no? Substitute this one, no? You can get your answer on this. Clear? So, this is just mathematics, just a substitution part onto this one, no? So, please try to substitute it and solve it this one. Now, we will go for one more question here, no? Right. So, this is a simple question, let us see. Therefore, here there is a system used to for the spraying the cars, therefore, colors, painting of the cars, no, will use electrostatics onto this one, no, because induced charges. So, a car body is positively charged. So, neutral droplets of paint, no, that can be attracted to the car. So, because the positive car body induces a charge on the droplet of the paint, which diagram best shows the charge pattern onto this one, no. Right. So, you know that, therefore, here in this one now, this side it is positive charge is there, this side also positive charge is there, therefore, this is wrong answer now, because opposite charges are going to get induced onto this. Therefore, so this part, this is not possible onto this, right. So, here also it is there, this negative charge is there, but here positive charge should be very far away onto this one, no. Therefore, this is not possible and only negative charge will not be there. So, this side positive charge it will be there. So, this is wrong. So, this is negative charge is there, this side positive charge, no. So, this option it will be your correct answer. Clear? Now, let us see. So, here the pendulum of mass 80 milligram and carrying a charge is given now, is rest in the horizontal uniform electric field. We want to calculate the tension. See, therefore, there is a one pendulum is there. So, therefore, here there is a one pendulum is there, this one pendulum having the charge now. So, here what we are going to do, we are going to give some amount of electric field here. So, therefore, what will happen now, this pendulum now, this pendulum it will go to here, right. So, this having mass m, so therefore, downward it will be like mg and this side it is nothing but a q times of your E electric field and this times it should be nothing but a tension here now. So, we want to calculate the tension now, therefore, making an angle theta here. So, therefore, here you can rewrite it as theta. So, therefore, T cos theta. So, balancing this one now, T sin theta. Clear? So, T sin theta is balancing Q times of E, T cos theta is balancing M times of G. So, therefore, you can rewrite it as R square it and add it, no. So, T sin theta whole square plus T cos theta whole square, it will be equal to, so T sin theta is nothing but Q E whole square plus mg whole square. Clear? So, therefore, here t square sin square theta plus t square cos square theta, t square means sin square theta plus cos square theta is equals to 1. So, t is equals to root of, so q e whole square plus mg whole square. Clear? Na? So, now we can rewrite it as charge. What is the charge here now? Charge is given, no. Therefore, 2 into 10 to the power of minus 8 into electric field is given how much now? 2 into 10 to the power of 4. Why? 20,000 it is there now, right? It is whole square plus 80 milligrams, no. 80 means how much now? 80 into 10 to the power of minus 3 into 10. Clear? Whole square. Right. So, what you will get it now here? So, therefore, here 10 to the power of minus 4 here, no? So therefore here we can rewrite it as, so this is 4 square, that is nothing but 16. Sorry, here 10 milligrams it is given. No, milligrams means how much? No, so milligrams means 10 to the power of minus 3 grams and 10 to the power of minus 3 kg into 10. Clear? Whole square, slightly clear. So therefore here 4 square 16, 10 to the power of minus 4 means 10 to the power of minus 8 plus, therefore here how much it will be? So here 6 means 2, therefore it will be 10 to the power of minus 4, therefore 64 into 10 to the power of minus 8. How much it will be now? So this is 6, 7, 80 it will be there. Therefore here you can write down 80 into 10 to the power of minus 4, sorry minus 8. So taken here, no, 10 to the power of minus 4 root 80. So root 80 means what, how much now? 8 8 is 64, 9 9 is 81. So nearly 8.9 something you will get it now. Nearly 8.8 or something you will get it. 8 point something, 8.8 or 8.9 into 10 to the power of minus 4 newtons. Clear? Right. So here what you can get it now? 8.8 into 10 to the power of minus 4. So this it will be your answer. Clear? Now we'll go for another question. Actually this question I already discussed in horizontal projectile motion, no? But here also we'll discuss because the electric field is given, no? Therefore how to solve this type of problem, no? Let us see. Horizontal projectile motion and this one. So there is a block shown in the diagram, no, has a mass of 2 microgram, no, and a charge of this one, no, therefore this much. If the block is initially provided with 2 meters per second, no, in the x direction. So therefore electric field of 2 into 10 to the power 2 Newton per Coulomb is switched on in the x axis direction. So therefore range of this one, right? So what will happen here now at this point? So if there is no electric field was there, see, if there is no electric field was there, what will happen now? If there is no electric field was there, u is equals to, so 2 meters per second. So it will be 2 meters per second. So what would have happened now? Therefore it would have come here, no, it will be having certain amount of range. So what is the formula for the range now? R is equals to u into square root of Th by g. So that would have done if there is no other force. But once it is released, so there is an extra force is acting onto this one. That means along the x direction also there is an acceleration is created now, right? So but here when it is projected like this, no, so projected like this, but coming downward, no, it is coming downward, it is coming downward is only because of due to gravity, because electric field which is provided, no, this electric field is making the object to move toward this side only, but downward force is only the gravity. So therefore it is coming downward only because of due to the responsible of gravity only. So therefore here downward it is coming is because of due to the gravity only. So therefore it will come down. So therefore, so because of due to gravity, no, the time period it will be equal to square root of 2h by g. So we can write it as 2 into h value is how much now? 5 meter. So by t value is 10. So therefore root 1, though, therefore time period, time taken it will be equal to 1 second. Clear? So therefore it will reach the ground in 1 second. Clear? So now, but in the x direction, no. So therefore it is traveling some x direction, no, x distance, no. So it is because of due to initial velocity u into t plus also there is some electric field is provided, no. This is creating an acceleration a into t square. Clear? So what will be the acceleration created onto this one now? Acceleration it will be equal to, so you know that therefore q into E by m. What is the charge it is given now? Charge is given as 2 into 10 to the power of minus 9. My electric field is how much now? 2 divided by 2 microgram. 2 microgram means 2 into 10 to the power of minus 6 gram, 10 to the power of minus 3 kg. So this will cancel now. So acceleration is nothing but a 2 meter per second square. Clear? So this horizontal direction, no, so here it is because of due to this velocity, therefore 2 into 1 plus 1 by 2, acceleration is 2 into 1 square. How much it will be? 2 plus 1, therefore 3 meter it will travel onto this one. Clear? So what will be the answer? Option D, it will be your correct answer. Clear? So now, okay, right students, thank you for watching. Please subscribe to my channel, no? So learn physics very easily through my YouTube channel. So please go through it, all the remaining other videos, no, which I uploaded, so that it will be helpful for your preparation for any competitive examination. Thank you.